Okay, so to do the 2-axis joystick will be very similar. We are on a knockoff of an Arduino, so we can use just the integer representation of the pin numbers to access it. So set up an int for x-axis, and that will be the x-axis is on A3, and then I'll add another comment in. The x-axis value coming from the joystick. I'll select that line, hit Control C to copy, paste that, and we have a y-axis on a pin A4, and these will also be inputs. So we'll set the pin mode for both of them. X-axis is an input, pin mode y-axis is also going to be an input. But we know this works, so I'm going to comment this out for now. I'll just do a regular multi-line comment to keep all that out of the way. And that way we don't clutter up the serial port with something other than what we're testing. And it will be very similar. We just want to do an analog read instead of a digital read. So we'll store that somewhere. Int x is an analog read on the x-axis pin. Int y is an analog read on the y-axis pin. And then we can print those off. So serial.print, using print instead of print line as an alternative to concatenation, and then do a print line at the end to get the next, just for the line break. So print the words x-axis, then serial.print what is actually in that value x, then serial.print ln for a line break, and repeat that for the y-axis. So Control C to copy, Control V, looking at the y-axis, want to know what y is, so that should print out and work for us. So I'm going to again do that from the phone video so that we can see the stuff moving at the same time and the outputs. So let's go troubleshoot this piece. Okay, so we're ready to upload this code and see if this next part works. So I'll hit Control U to compile and upload the sketch. And might have to make some adjustments because one thing may not show up very clear here on the phone. There's not really any labeling on that joystick. So the pins that say x-axis and y-axis are labeled, but there's no label showing how it should be oriented. So the position it's in the board might be a little bit different than what the pin labels say. So it's uploaded. So if I come over here, probably use a couple line breaks. It looks like right in the middle, both of them are reading about 5 something. So I'm going to try pushing this to what I think is the left, so the negative x. So we can see the y-axis is 1023 and the x is still around 500. So that means that point I just mentioned, yes, the x and y labeling is reversed because of the position that I put this in. So go back to the middle and I'll push to the right. Pushing to the right, we can see the y is way down at 7 and the x is still around the middle. So that was pushed to the right and left. So that is what the computer thinks is the y-axis. So we'll probably change those labels so that the code makes sense. Because the only thing that actually says x is the little label right here. So Now check the other axis. It's still around 500, so if I pull this down, what seems down from the orientation puts the X at 1023, back to the middle, push it up, and now the X is at 3. So I'm going to grab a piece of paper and jot that down. So the X and Y names need to change, but up is apparently negative, the low values. Down is the high values. Left is the high values. And right is the low values. But that's a little counterintuitive. So I'm going to make some notes about that, and then we'll adjust the code to match what it feels like the joystick should be on the X and Y axis. So as you can see from the picture there, I jotted down some quick notes about what the joystick is actually doing currently and what I want it to be doing. And we can make those changes in software. So right off the bat, the X and Y axis are relabeled. So the quickest place to change that is probably right here. So what goes in pin A4 went to be the X axis or horizontal axis, and pin A3 I want to be the vertical axis as far as the software is concerned, and the orientation for how I'm going to hold the controller. So that'll change all of those. That'll be good. That should give us the low values and high values in the correct orientation now. So if we hit Control U to upload this and check, well, actually, before we check, we can probably add a couple print lines to make that easier to read. Some gaps in there. Probably could have done that a moment ago, so re-upload that. Instead of having every line right next to each other after every pass through our main loop, which is the built-in method that just runs until we disconnect the power. So now we can see right in the middle, everything's around 500 something. So now if I move the joystick to the left, X is 1023, and to 0 to the right, moving it down is 1023, and moving it up is the 0. So I want to reverse those. So what I'm going to do is remap it. So we have another built-in function we can use called map, where we can just map that to a different number. So instead, we're going to take whatever number that gives us, and we're going to remap the number 0 to 23 to something else. And ultimately, in the end, I want this mapped to between -1 and +1. But we can do it in a couple steps. So first off, let's just map this to the reverse of what it is. And since it hasn't been mentioned yet, instead of just typing that in and talking about it, why don't I pull up the actual API and look at the documentation for the Arduino IDE real quick. So if we open a new tab and just Google map in Arduino. Arduino.cc is the official page. So this will jump right to the API documentation. So we can go in here and get all the information about this built-in function. Map, some math stuff we do. So from a low number to, we're mapping from something to something. And here's our syntax. The value we want to change. What's the low value that it would have been? So from is the range it would have been. So for us, that's 0 to 1023. And what are we mapping it to? Too low, too high. So instead of going 0 to 1023, why don't we go -512 to +512? Or something, maybe just -100 to +100. And then that we can take as percentages when we get to the other side. So from -100 to +100, and then that'll give us like a percentage of how far it's moving, and we'll have a nice integer to work with. And so we'll just remap it that way. And then this is what the documentation our Arduino stuff looks like. You can see it's full of examples of how to use it and everything. It's like read. This is almost exactly like what we want. Analog read some pin. We're going to map the value that's read in, which initially an analog read goes from 0 to 1023, and we're going to remap it. And the example 0 to 255, but to consider a percentage, let's go from a negative 100% to a positive 100%, or negative 100 to positive 100, and we'll just treat that as percent in our script. So back over in our code, we don't want X to be the analog read. We want to map that analog read, which originally went from 0 to 1023, and we want to go from negative 100 to positive 100. And the x-axis was actually backwards. It had 0 on the right and 1023 on the left, so I'm going to flip those and go from positive 100 to negative 100. So you can just flip it right in the mapping. And same thing for the y. We don't want the analog read. We want to map the analog read, which originally went from 0 to 1023. And again, well, the y-axis was okay. I think. I should have jotted down a note. I think maybe the y-axis was backwards too. So we'll go from positive to negative 100 and flip the direction as well. So let's save this and re-upload that and see if that gives us some good values to work with. It's done uploading, so back over to the serial monitor. So right in the middle, I'm not touching the joystick right now, and it's pretty close to 0. So I'll push left and see x-axis is negative 100, and I'm kind of wiggling around. It's very sensitive. Back to the middle, push to the right. Positive is to the right is a positive 100. Going down is negative 100 on the y, and going up is a positive 100 on the y. And then we can hit all sorts of different values in between by just spinning the value around. So then that'll work as percentages, which when we get to control, those percentages of the left, right, up, and down can apply to the speed at which the thing we're controlling moves. So it looks like that works. So that finishes up the initial troubleshooting section. So the next section will be actually starting the protocol. We don't want this to return all the time. We only want this to return when a certain instruction is sent to it. So yes, so looks like the initial troubleshooting is good now. The buttons are registering whether they're being pressed or not, and the joystick is registering a percentage of which direction along the axis it's pushed, and then we can use that percentage to adjust the speed the thing we're controlling actually moves. But just one little step at a time. So next off, we have to set up a protocol so that when an instruction comes down the serial port, our device responds with the right value that instruction was asking for. But before we jump into that next section, let's update our documentation so we don't fall behind on this. For example, in the setup method, now we have a couple more things that it does. So we can just kind of add those sentences in here. The generic initialize method for the controller. Set up the serial port, serial COM port to a baud rate of 115,200. Oh, I should set up the serial COM6 port because we'll need that. We'll need to know which number it is to a baud rate of 115,200. Put in a line break for when it generates it. So we do need the regular line break character. And what else do we do? Initialize the buttons and joystick pins to input. And while we're here, we could put some stuff on our main page. if I pull up that one we generated previously, oh, you see the main page is empty. So we can put some stuff there as well. And we do that in a very similar fashion. We'll, at the very top, first thing in our document, we'll add another one of those special comments Doxygen will recognize. Only this time we need to add in some keywords that it will look for. We will look at the documentation before long. The documentation there is kind of overwhelming. That's why I wanted to do a few pieces at a time along the way. But there's several notations. I use the one like Java Docs, so we can use the @ symbol to refer to our keywords. One of those being the main page. So @main page, and I'm going to call it, then a name for it, basic control unit. So that'll put a label on there. And that main page is going to have different sections on it. So then we can do @section. Well, we'll have a description section. And then what do we want to call that description? Well, I'm going to call it summary in this case. And I'll put a small control device modeled after the classic Nintendo Entertainment System controller. That was my inspiration, but I think we've already kind of gone a long way from that mid-80s one that I have fond memories of back in my childhood. So that's to be used in educational video games and for general mouse functionality. So just kind of add in a couple little sections. Another section we have, might as well go ahead and sign this. So we also have a section for author. So at the section author, and I'll go ahead and just call this one author, and put in the line developed by Christopher S. Francis. So I started yesterday, so 17 November 2022, and there's no telling how long it'll be before this is finished, but have the start date. So I'm going to save that, and now I'm going to rerun that Doxy wizard, and this time let's send the output to the correct location. So over here in the File Explorer, I have the folder set up where I want to send that to. The last output I just copied and pasted over, but might as well just send the output here to begin with. And in the Scratch folder is that Doxy file. So I'll right click on that and open with Doxy Wizard. So a couple small changes here. Particularly the output, the destination folder. So we'll select a folder. We don't want to output to the Scratch folder. We're going documentation and docs and send it here, and it will output a folder called HTML that is just filled with files. So if we look at that, here's all the files that it generates for putting that web page together. So back over here, so that ought to be good. Haven't changed anything. Don't need to remap anything, any languages it doesn't know about, or all the input settings should be the same. We're still generating the same thing. So really the only change is where that output is going. So go ahead and run it. It'll just take a second, and it should have replaced this version right here. So if I hit reload, oh, there's that stuff at the top, things to put in the main page, and we do that with these keywords in our code. So at main page, we have a section for the description, a section for the author, and you can see we have our description and the author now. If we come over to files, Here's our documentation for the INO file. You can see we have our two methods, which the setup method now says a little bit more. And notice just the regular old \n line break escape sequence gave us multiple lines here. So we want to do that. But we can also pass in HTML code because we are writing a web page. And we also have descriptions of the variables we use from those inline code, from these inline documentation things. So once again, very, very useful. And somebody, if they want to know about our project, they don't have to go through and read the code to see the comments and figure out what it is. We use the comments to generate a website that documents our project. So now we're ready to move on and get started with setting up a protocol so that these instructions, the state of the button only comes when the software on the other side asks for the state of the button, or the x-axis controls only come when the software, say the game engine that it's controlling the game on, ask for the value from the joystick. So let's get started setting up that protocol.